Hey everybody, this is Larry. This is me doing week 5 of the August Leetcode Premium Daily Weekly Challenge, whatever it's called. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. We have the 1182 shortest distance to target color. Alright, let's see. You're given you're given an array colors in which there are 3 colors, 1, 2, and 3. You're also given some queries. Each query contains 2 numbers, I and C. Return the shortest distance between the given I and target C. If there's no solution, return -1. Okay, I mean, there are only 3 colors, so you can just store all the indexes, right? And then just do a binary search or something like that. That's how I would think about it, because everything is log n. I mean, I probably should double check on the constraint, but if log n is not fast enough, you're gonna have issues with whatever you want to do. But the pre-processing is pretty straightforward. It's linear, right? So that's enough for me to kind of. I know that I went a little bit fast, but and maybe that's a little bit more real time. But it's just about. But I do want to put some emphasis on that. I did do the complexity analysis before kind of typing. But in any case, yeah, yeah, and then it's just for I, X, or C maybe in enumerate colors, index C sub C's, append I. So then now we have the index C's mapping every color C to the index C's. And then now it's just for IC in queries, right? We have answer, and then yeah, if there's no solution, I mean, there are no solutions if that colors don't exist, and that's it. So if C is not in index C sub C, no, that's not right. C is not in index C's, answer that append -1, and then we continue, right? Otherwise, then we are good to go. We just do a binary search on something like this, right? We could do a bisect left on this and I. So bisect left will give you either exactly I or the next number after I, right? The next indexes, right? So that means that you either add I or going over. So you have to go to the previous one to also check which one is closer, the shortest distance, right? So that's basically it. So mail chord right is equal to this, left is equal to right -1. Yeah. Trying to think. No, I think that's fine. I mean, I think that right can be 0, so I think that's the biggest thing. But yeah, but maybe I could just actually write something like answer dot append. What we want to do? Index. Then yeah, index C sub C of right, that return the index that we got. And then now if right is greater than 0, that means that you want to take a look at the left side. So left is equal to right -1, and then if answer, the last number that we used, maybe you could write this a little bit better actually. If this is if this -I, you could probably do it without absolute value, by the way, but I don't like to prematurely optimize, or I mean sometimes I do, but this one I'm lazy. Okay, if this is shortest distance, no, the other way, because then now if index C's of C of left is, if this index C is shorter, then now answer of is equal to index C's of C of left, right? And that's it. Should be okay. If you don't go out of bounds. Why would you go out? Oh, of course, actually. No, that makes sense. So you go out of bounds when none of the numbers are, or all the numbers are smaller, so we have to adjust for that, right? So if right is less than length of indexes of C, then we could do this. And we put this here, because if otherwise, then we just by default, and we know that this exists, otherwise we wouldn't have it here, right? We just do the biggest number, right? Biggest index of that color, and that's it. That's what I thought it would be anyway. Did I misread this? This is color 3 index 1, right? Oh, you have to do steps away, not the index. Okay, so I mean, I'm kind of right? Because 4, 2, and 3 is the index that we care about, but this makes it actually a little bit easier. Maybe, I don't know, right? Because then you can just do I minus this, right? And then here you don't even, you could just do a min. Is what I would. Why does it slightly easier? Right? Oh, I have to do this one too. Okay, now it looks okay that we read the question, so I think let's YOLO submit. Hopefully no silly mistakes, and we look okay. That's it. What's the complexity here? The pre-processing is linear time, linear space for every index. Well, linear in colors, because I guess queries is part of the input as well. But yeah, linear time, linear space, and colors. For each query, it is going to be log n, right? No getting around it. And O of Q space also, obviously, because that is just the size of the answer array. And that's it. That's all I have for this one. Go keep it short and sweet. Let me know what you think. Thanks for watching. And yeah, how did I do it last time? It feels like, I mean, I know that I don't usually look at the thing, but I thought I saw something like longer. No, I guess that's pretty okay. Oh, I actually, no. I guess last time I did DP. I just pre-processed it from the left and then do it from the right and then just get the answer. And then this just allows me to do O of 1. So this is 3 times N plus Q. I don't know. I don't know if it's, I guess that's interesting. I mean, the trade-offs are not super clear. I mean, with 3 colors, maybe that's fine. I don't know. I mean, I think ultimately it depends on the size of your input, right, and stuff like that. You could maybe play around with, I don't know. It's interesting. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. And as you saw, apparently you could do it at least 2 ways. So yeah, stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.